Hi everyone, and welcome back to Educator.com. In this mini lesson, we're going to go over page 1 of the A+ Physics worksheet on wave basics, and you can find a link to that worksheet down below the video. So let's dive right in. Which type of wave requires a material medium through which to travel? Well, waves that require a material medium are mechanical waves, and the mechanical wave here is sound. It needs to go through air, or water, or metal. It won't travel through a vacuum. These other three are all electromagnetic waves. They'll travel through a vacuum. They don't need a medium. Number 2, a single vibratory disturbance moving through a medium is called a pulse, one of our vocabulary words from our wave basics lesson. Number 3, the diagram below represents a transverse wave traveling to the right through a medium. Point A represents a particle of the medium. In which direction will particle A move in the next instant of time? Well, right away, since it's a transverse wave and its velocity is to the right, we know that A can only move up or down. And as the wave travels to the right, A is going to go down next. So our correct answer there must be number 2. Number 4. As a transverse wave travels through a medium, the individual particles of the medium move perpendicular to the direction of wave travel. That's the definition of a transverse wave. Number 5, a periodic wave waves transfer energy. Our answer, one energy only. Number 6, which type of wave requires a material medium through which to travel? Well, waves that require a material medium are known as mechanical waves. These other three, again, are all electromagnetic waves that don't require a medium. Number 7, a ringing bell is located in a chamber. When the air is removed from the chamber, why can the bell be seen vibrating but not be heard? Well, the reason is that light waves can travel through a vacuum. They don't need a medium. Sound does. If you take all the air out of there, you've probably gotten rid of most of the medium through which the sound can travel. So light can travel through a vacuum, but sound cannot. Number 1 must be our best answer. Number 8, which statement correctly describes one characteristic of a sound wave? A sound wave can travel through a vacuum. Nope, that's not it. A sound wave is a transverse wave. Also not true. Sound waves are longitudinal or compressional. The amount of energy a sound wave transmits is directly related to the wave's amplitude. That is true. Amplitude corresponds to the energy of a sound wave. Correct answer, number 3. Number 9, a television remote control is used to direct pulses of electromagnetic radiation to a receiver on a television. This communication from the remote control to the television illustrates that electromagnetic radiation is a longitudinal wave. No, EM waves are transverse. Possesses energy inversely proportional to its frequency. No, it's going to be directly proportional to the frequency. Diffracts and accelerates in air. No, goes at a constant speed in air, 3 times 10 to the 8th meters per second. Transfers energy without transferring mass. Yes, waves transfer energy. Correct answer there is number 4. All right, last one. The diagram below represents a transverse water wave propagating toward the left. A cork is floating on the water's surface at point P. In which direction will the cork move as the wave passes point P? Again, it's a transverse wave, so the direction of the cork must be perpendicular to the wave's velocity, or up and down. As the wave moves to the left, our cork is going to go down, then up, then back down. So our answer must be number 2. All right, hopefully that gets you a good start on wave basics. If this went great, terrific. Go ahead, keep moving on. These aren't quite at the level of AP questions, but at least a check of fundamental understanding. If it didn't go well, now would be a great time to go back and review the lesson on wave basics. Thanks so much for your time, everyone, and make it a great day.